How we doing, everybody? All right. How's everybody doing out there today? Oh, no, my light's gonna fall. Don't fall away. All right. Just look at the line. Over that, just a wee bit. Why is that mic picking that up so much? No, that's good. All right. Well, hello, everybody. Glad to see everybody here. Yeah, so I guess a quick update. Let me just get over to the Twitch. And all right. So just to give everybody a quick update. I pushed back the stream a half hour, Monday through Friday. I pushed it back to 5:30 Eastern Standard Time. I hope that doesn't deter anybody from coming to the stream or whatnot. This was for me. This was to give me a little bit of a buffer zone, I guess. Just again, because I mean, if you guys have caught the last couple of streams, I'm pretty wiped out by the time I'm I'm ready to stream. You know what I'm saying? That's because I'm rushing around trying to get everything done because, you know, I'm getting dinner done for the kids. I'm trying to get all the VMs and everything else ready. And because what happens is I'm just waking up about an hour before I need to start stream. Well, an hour before at least I scheduled the stream. So, you know, with me getting up around 4 o'clock because of me working the overnights now, it really been putting a stress on me mentally and physically at the same time. And again, what it was doing is I was become overly, I guess I was becoming so stressed out that the quality of the stream, my quality of my attention that I was paying to the stream was really lacking. And I mean, there was moments where I was starting to doze off halfway through the stream, and that's not at all appropriate for, you know, for me to be doing for you guys. You know, this is supposed to be studying. We're supposed to be hardcore into these studies here, and you know, not dozing off like we would in class. Yeah, so I gave myself a half hour buffer zone. I put it in the schedule, and if it didn't update today, I'm sorry, but I apologize for that. Again, I just needed a little bit of a buffer zone to give me enough time to at least eat dinner myself. You know what I'm saying? Because what happens after this is right after I'm done streaming, I'm rushing now to go to work. So again, it's nothing, I guess, that you guys should be concerned about. It's more on me ensuring that I'm not burning my candle on too many ends and then, you know, burning out completely. Yeah, that's the last thing I guess that's the last thing I need to do for everything is to burn out completely. You know what I'm saying? So that's it. That's just a quick update. Again, you know, if that's an inconvenience, I apologize for that. This buffer, the zone now is for me to make sure that I'm giving you guys in this stream the appropriate attention, and that my mental and physical self is ready to do this. So was just adding to the quality. Hope you guys like the new layout. I updated it over the weekend. I actually streamed that too. It's my in real life IRL streams that I'm gonna be doing on my phone now. My in real life streams with Joe. You guys, if you guys caught it, I was doing some cooking and some baking. I got some more. I got plans for that too. So there's gonna be a whole in real life with Joe streams coming your way. The Discord, guys, the Discord is just about finished. It's just a couple of more things I want to touch up on it. I got my Joe bot up in there already. He's doing big things. He's notifying. He's talking to people. He's answering your questions. So pretty soon, guys, the Discord would be up and running. So there would be more integration with there at least will be the full circle dynamic that I'm looking for the stream, and for the studies as well. Because what it'll be, I'll be adding these labs that I'm creating in Packet Tracer and in Cisco Modeling Lab. I'll be adding those to the Discord, so you guys be more than welcome to download those and then play with them yourselves. There'll be plenty of information on there, links and whatnot, to get you guys the appropriate information that you guys are looking for to continue on your studies, and to spike more interest. There'll be some creative channels as well, because as this stream has been growing and is in with me trying to dive into being more and more creative here, I've stumbled upon, you know, my own creative side, and I've been enjoying expressing that. So there'll be a whole creative side where you guys will be able to express your creative abilities and stuff like that. Again, the Discord and like everything else that I'm trying to put out there it's going to be strictly, there's going to be limitations to what I will allow, though, okay? There won't be no inappropriate stuff, all right? Because what I want total inclusion for everybody, all right? I don't want anybody to feel uncomfortable on my Discord, in my stream, on my YouTube channel, nothing like that, okay? So what that entails is there has to be limitations to what will be allowed visually, what will be allowed to be, talked about and stuff like that. So again, so that's why I've been taking, that's why at least I've been taking my time, at least with the Discord and stuff like that, just because I have to, I'm trying to make sure that I allow certain things, but then I don't allow a lot of things else. There's a lot of things I don't want to allow. And that's just to keep things appropriate, guys, keep things inclusive. You know what I'm saying? Because, I don't want, oh, what happened? Why did this just drop off like that? I allow certain things. Yeah. So, I was wondering why they dropped off like that. So that's the size of it. You know what I'm saying? Yeah. So let's without further ado, let's just jump right into it, eh? What's the matter for you? Hope you guys like the cool neon scene I got. Alright. That's set up. So I'm gonna make sure. I believe I got everything set up right. I believe. But changing my scenes like this, sometimes. Just want to make sure I get them good there. So that's it. Alright. Alright, we're good. I didn't break anything. Alright. That's there, right? That's me whiteboard. That's that. Alright. Whoa. Breaking stuff again, guys. I'm breaking stuff again. Packet receipt. Alright. Alright. Let's dive into it, guys. Get everything up. Everything's good. Kill the music. Alright. We're good. We're good. Oh, you know what I didn't add? I didn't add my little thingamaboober. Let me add that real quick. Hold on, guys. Oh, much bigger we need it, man. There we go. All right. That's all I needed. All done now. All right. Let's get into it, everybody. Grab my stuff. Oh, what up, Jay? Joey the Dino. What up, my man? How we doing, brother? Welcome to the stream, my friend. So I don't know if you checked out what we've done here. So just to give you like a quick synopsis of what I do. So I'm going after the CCNA certification. So it's like it's a Cisco certified network associate certification. So my stream is like it's a study to go after IT certification. So we're going to be going after the CCNA. We're going to be going after DevNet. We're going to be covering a lot of the Cisco certifications. And then from there as well, we're also going to be covering some Linux server stuff, some Red Hat Linux stuff, so on and so forth. So yeah, man, welcome to the stream, Joey. Hope you enjoy. How's your day today, my brother? Hope you're doing good today, man. Hope you're doing good. Thank you so much. You pump me up right now, Joey. You pump me up. Gotta erase my board. My wife was getting crazy with my whiteboard today. Well, not today. It was over the weekend. We were what were we doing? We did a stream with I'm trying to do these other just working. I figured I would check in on you. I did. Such a great one, man. You're a great dude. You can learn and utilize these skills going forward. Thank you, Joey. I appreciate that, brother. Appreciate that, man. Hope you had a good day at work, man. I think you were saying you work from home and stuff like that, man. That's pretty cool. That's what hopefully I'm achieving. Hopefully, with all these IT certifications or whatnot, hopefully someday. That's what I'm aiming for, man. Is get a nice job like that. So, to just make a decent living and whatnot. You know what I'm saying? A comfortable living. So that's what these certifications are going for. And I'm in school too right now, trying to get my bachelor's degree as well. So, all to get that. Because right now I'm stuck again back in retail, as much as I hate retail. All right. All right. So what we're gonna start with, and what I usually start with is a recap of what we've been on what we've been studying. So over the last couple of where's my mouse? Over the last couple weeks, we've gotten to part 1 of the CCNA book, part 2, and now we're in part 3, and we're now in part 4. Part 4 is taking a little bit of time. Part 4 is all about IPv4 routing. I've taken a little bit of time because I want to make sure not only am I understanding the fundamentals of how an actual router routes packets. I want to make sure that I'm expressing and coming across clearly on how routers completely route packets. Say the internal workings of how that information is getting from the router through the wire to the other router or to the host, wherever that packet is going. So that's taken us a little bit of time. I got Cisco Packet Tracer on another VM that I got booted up right here. And then that's another thing, Joey. I do a lot of like virtualization as well. So I got virtualized. I got a couple different virtual machines. I got my server up right here that I host a whole plethora of different types of virtual machines and whatnot. I got Ubuntu. I got some Linux virtual machines up in here. This is Cisco Modeling Lab right here. This is it's what is it? A CentOS? Yeah, it's a CentOS based virtual machine, but it runs a program called Cisco Modeling Lab, and Cisco Modeling Lab is it's a networking emulator. So if you ever heard of GNS3, this is GNS3 right here, or EVA, yeah, EVA, EVNG, EVNG. That's the other one. That's another big name. They're network emulators where what they do is they emulate the actual networking devices images. So the actual operating systems that the networking devices use, they emulate that into a real program, and that's what these other programs right here are doing. I also got I've been playing around with things. I've been also playing around with pfSense. pfSense is it's a Linux-based operating system made by pfSense. It's all open source. That what it is, it's a virtual routing image where I have this set up on a different virtual switch. Where's my other virtual switch? There we go. So this is my virtual switch that I got built inside of my my virtual server here, and this is where I do other types of labbing and stuff like that in here as well. This is all based off of all networking labbing, virtualization labbing, and whatnot. So that's just a little bit of the quick and dirty scoop. So again, we're going to be getting into. We need to do a quick review off of what we've been studying as of lately. So what we'll do is we won't do the full gambit, because the full gambit I believe is like 150 questions or whatnot. So we'll do a partial. Oh, really? Oh, that's awesome, dude. Oh, I didn't know that, Joey. Yeah, so that's what I've been trying so hard to get into, like some kind of like even junior networking or junior tech-based IT job. And what the whole thing is I might know how to do all these things, but I don't, because I haven't worked, quote unquote, worked in the industry yet. A lot of these companies have been, just taking my resume and saying, "Oh, you're not qualified yet. Oh, you're not qualified yet." So that's the real push behind me going after these actual certifications. Is I'm hoping by getting these certifications that as I continue to, put my resume out there, eventually somebody will give me, again, even just for like a junior type position, just to get my dabble my toes in the water of actual IT work. But hopefully that will come. Again, I just, my whole focus is if I can, and that's what part of the stream is about too, Joey, is if I can I guess, demonstrate what I can do and my knowledge base. I'm hoping that a future employer will actually take the time to look at, just some of the work, because I do this streams also on to YouTube and whatnot, so they can go back and just take a look at some of the stuff that I can and do know. Again, just to it's like this is my attempt to my virtual portfolio, I guess you can say it as, but that's cool, man. All right, let's do exam 1 and exam 2. Let's unclick this one. All right, chapter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. I know I'm gonna get caught up on chapter 15 and 16, but we're gonna push through it, and we're gonna see how many questions this gives us. All right, IP functions at what layer of the OSI reference model? Now remember, don't get hung up on the OSI and the TCP model, because they kind of reference each other, even though the TCP model is the model that exists now, but they still refer back to the OSI model. All right, so again, IP functions at the layer 3 model. All right, layer 3, which we're over here in networking. Okay, all right, which of the following terms represent an L3 PDU in the OSI model, which includes the network layer? Again, so there's that word again, network layer, header and an encapsulates data. Okay, so layer 3, we're dealing with packets at the layer 3 level. Okay, all right, the term segment refers to which layer PDU? Okay, so again, as we step up on the OSI or the TCP model, or I like to refer to it as almost like a ladder, because you can only go up a ladder and you can only go down a ladder. You can't just over jump it, or you're gonna hurt yourself. You can't just jump to the top tier of the ladder, or you're gonna hurt yourself. So again, we're taking the next step up. So that's layer 4, which is the transportation layer. Okay. All right. In the figure, Cat5 cabling with RJ45 connectors is used. Which of the following statements are true about the wires included in the cable and the RJ45 pins in which they are connected? All right. So again, when we're thinking about wiring and stuff like that, we kind of want to put things where they belong. So PCs, all right, routers, all right, and access points, they all have the same, these things have the same logic, okay? Switches, all right, switches, bridges, all right, and the things you probably might still have or are hopefully phasing away, hubs, all have the same logic. Because if you could think about it, bridges, hubs kind of came first, then there were bridges, and now there's switches. So these all have the same type of logic, okay? Now, when we're connecting a PC to a switch or a router to the switch, okay, we're using straight through cabling, because what it is I'll draw 2 lines. So on a PC, we'll just say, for instance, one wire is transporting, and the other wire is receiving. Same thing on here. He's receiving on this end, and he's transporting on that end. Okay, so we're using straight through cabling. Okay, but if we were connecting a switch to a bridge or a switch to a switch, the problem is they're both transporting on the same, and they're both receiving on the same. So when we're connecting a bridge to a switch or a switch to a switch, we have to use crossover cabling, okay? That way we ensure that the pins on either one is going to the transporting end and one is going to the receiving end, okay? All right, so that's the type of logic we have to be using. All right, so let's read so how many do we have to select? Sometimes these questions, you just have to make sure you get, it asks us for multiple answers, but this one may only be one. So the cabling from SW1 to SW2 connects on pin 6 on one end and 3 on the other. Nope. The cabling from PC1 to switch 1. Nope. The cabling from switch 1 to switch 2 connects on pin 1 and pin 8. Nope. And PC1 to switch 1 connects on both pin 6 and pin 6. Yes, it does. So it's the last one. All right. All right. The network in the figure uses Cat5 cabling with RJ45 connectors. Which of the following statements are true about the wires inside of the cabling in the RJ45 pins in which they are connected? Okay. Now again, let's make sure we select 2 because it's annotating. We need to select 2 right there. Okay. All right. The cable from SW2 to R1 connects on pin 6 and pin 6. Yep. Okay. The cabling from PC1 to switch 1 connects on pin 2 and pin 3. Nope. The cabling from switch 2 to R1. Nope. The cabling from switch 1 to switch 2 connects on. Nope. And the cabling from S2 to S2. Nope. And hold on. Is it this one? Let me just take a second to think about this one. Yeah, it is this. Because, so on a crossover and cabling, I just had to think about that for a second. So on a crossover cabling, pin 1 on a crossover cabling connects to pin 3. Pin 2 connects to pin 6. All right. It should be good. Yep. All right, we're good. I just had to think about that for a second on the crossover cabling. All right. Refer to the diagram. The new connections that's going between campus 1 and campus 2 routers is required to provide 500 megabytes per second of bandwidth. The routers are at least 3,000 meters apart from each other. Which standards of Ethernet should be used in this situation? So we have to think big. They need 500 megabytes per second. They need 3,000 meters. So we need to think big. So we need to think Zulu. Okay. When we think big, we think Zulu. Okay. So Zulu is I have it up on my board too. Zulu is it's 1,000 base LX. So that's 1,000 megabytes per second of fiber optics, all right, which can get you a maximum length of 5,000 meters, okay? So since they need that first off, that length of cabling and the greater bandwidth, so we need to get the right cabling that they need. So it'll be 802.3 Zulu, okay? All right. The diagram refers to which types of fiber cabling, okay? Now when we have a bigger core in the fiber optic cabling, all right, when we have a greater core in the fiber optic cabling, all right, what that is permitting is for that light wave to be bounced off of the cladding. So the cladding that's outside of that core, all right, when we have a bigger core, that light just bounces off it, okay? Now, when we have a smaller core, all right, that light doesn't bounce off that cladding so much. So this will be multi, okay, where this will be single, all right? We call it multi because the light waves are being bent and bouncing around that core so much, where a single, it should just be a straight shot all the way through that fiber optic cable in there. So we're going to go multi-mode. All right. The diagram shows a simple internetwork in which All local area network connections use fast Ethernet. All right. Select the answers that list the correct cabling type. All right. So we got to select 2 answers. A crossover cable between switch 1 and switch 2. You know it. An Ethernet crossover cable between. Nope. The Ethernet crossover cable between. Yep. All right. So that was easy. All right, let's move on. The network in the figure uses Cat5 cabling with RJ45 connectors. Which of the following statements are true about the wires inside of the RJ45 pins which they are connected? Okay, we got to select 3 answers now. The cable between PC1 and switch 1 connects pin 1 on one end, pin 1 on the other. Yes, that's correct because it's straight through. All right. The cabling from switch 1 to switch 2 connects to pin 1. Nope. And pin 1 and pin 1. Nope. The cabling between PC1 and switch 1 connects to pin 1 and pin 3. Nope, because that's crossover. The cable between switch 2 and router 1 connects to. Nope. Wait. Yep, that's actually right because that's straight through cabling, baby. That's what we want. The cable from switch 2 to router 1 connects to. Nope. And the cable between switch 1 and switch 2, again, pin 1 to pin 3 on the crossover, and then pin 2 to pin 6. All right. Send it. All right. Which of the following data link layer protocols are used to encapsulate data on a leased line? Okay. Which of the following data link protocols, okay, are used to encapsulate data on a leased line? All right. So that'd be point to point and HDLC, high data layer control, high data. That one I always forget. I need to look that up because that's gonna irk me if I can't remember that. It's high data. It's high level. High level data link control. High data link control. That's what it is. Let me just confirm that. Just confirm it. I don't ever like to put out information that I'm not half sure about. HDLC, high level data link control. Okay, a bit-oriented synchronous data link layer protocol developed by the International Organization of Standardization, the ISO. Okay, so high level data link control, HDLC. All right, I love the acronyms. They got acronyms for days. All right, and PPP, I'll get you the terminology for PPP2. Again, the acronyms, sometimes I like to just go over the acronyms because sometimes there's way too many acronyms. Where's the PPP one? PPP is point to point anyways. I'll get that. I'll get the, it's not in the index for some reason on that one. All right. Based on the diagram, host A sends a packet to server B. The two serial links use HDLC while the rest use Ethernet. How many times does that packet experience re-encapsulation by a router? Now remember, this is what we were going over the last couple of days with IPv4 routing. Okay, when a frame enters a router, all right, that router de-encapsulates the IP packet from the frame, all right, from the Ethernet frame. It takes the IP packet out of that Ethernet frame, okay? It takes a look at that routing information. It makes a smart decision about where to forward that IP packet next, and then it re-encapsulates that packet either into an Ethernet frame or an HDLC frame, and then forwards it out its other interface, okay? So what's going to happen is every time that frame, that packet hits it, it's going to be, all right, it's going to be, so it's going to hit here, all right, and then it's going to be sent out here, okay? Now, it's going to be re-encapsulated 1, 2, 3, 4, 5 times. Okay, 5 times. That packet's going to be re-encapsulated, and it's going to be de-encapsulated and then re-encapsulated 5 times. Okay, before it actually hits that host. Okay. All right. How does the receiver of a HDLC frame know what has been encapsulated within that frame? Okay, that's in the type field header. The type field header. Which protocol finds an unknown layer 2 address from a known IP address? Okay, which protocol finds an unknown layer 2? Layer 2, remember, layer 2 is MAC addresses. MAC addresses, okay? That 48-bit long, unique identifying code that your NIC has, your network interface card has, okay? So, I guess it's really not for me to draw. But it's, so we got to think about layer 2, okay? So, your host, me the host, I might have an IP address of host Bob down the street here. All right, I might know Bob, all right, but I don't know Bob's per se full address. So what I need to do is I need to find out Bob's complete address before I can send Bob an actual message. So I blast out, okay, an ARP, an address resolution protocol, all right, and I broadcast it out, okay? I send it out to the address FFFFFFFFF, okay? That's going out to pretty much everybody and anybody, and I'm going to be asking everybody, okay, who is at 10.1.1.2, all right? I need to know his layer 2 information. Does anybody know the layer 2 information of 10.1.1.2? Can somebody tell me? So that's ARP, okay? Address Resolution Protocol, all right? What is the name of the Cisco iOS command line interface exec mode that allows a user to run powerful commands? Okay, so that's enable mode. Which of the when a Cisco iOS command line is initially accessed via console telnet SSH with no extra privileges, which mode is the user placed in? So you are placed in user mode. Okay, user mode. All right, refer to the diagram. Which of the following connection parameters are used when connecting to the console of a Cisco switch? All right, so that is the 9600 8-in-1. 9600 8-in-1. All right, so when you're using like a software or a program like PuTTY or something like that, that would be the parameters. So the that you'll be using to connect to a network device, okay? All right. After power on, a frame arrives at a switch. The switch had not yet learned the source MAC address of that frame. Which of the following must the switch take in this case? All right. The switch checks for the frame for loops. The switch adds the source destination MAC address to its MAC address table. The switch adds the destination. The switch adds the source MAC address to its MAC table. Let's read this again. The switch adds the source and destination. No. So the switch, all the switch wants to do. So when that frame comes into that switch, depending on what port that frame came in, say that frame came into gigabit 0-0 over here, all right, and that frame comes in, that frame is going to have a MAC address, a 48-bit MAC of some host over here, host Bob, okay. So, and that frame's going to go out whatever, 50 whatever, all right. That switch, it just wants to know where that frame came from. It wants to know the interface it came from, so gigabit 0-0, and wants to know the MAC address of the source. It don't care too much about the destination, okay? All right? The only thing it's going to do with that destination is is off of, if it already knows where that layer 2 information needs to go. So if it knew that out gigabit 1-1, that's where it might be sending that frame or whatnot. All right, then it'll look at its MAC table for that information. But again, switches work at layer 2. All right, layer 2. All right, they don't do IP forwarding or anything like that, unless you had a layer 3 switch. Now that's a little bit different. All right, but we haven't got that far yet. Okay. All right. All host switch ports reside in VLAN 1 with no port security and no static MAC addresses, tables, entries defined. Host B remains powered off, but all other hosts can ping each other successfully. Later, host B powers up, and the user issues the ping 10.1.1.4 command to generate host B's first network traffic, which answers describe the frame forwarding in this scenario. Okay, so what's this scenario telling us? Okay, it's telling us that B over here, my boy Bob, my boy Bobby Bob's, all right, my man Bobby Bobby's, he hasn't sent out any network information yet. He hasn't forwarded any frames. He hasn't filled up any. He hasn't done any ARP requests. He hasn't done none of that yet. Okay. So when he fires up and he issues the ping to 10.1.1.4, which is my homie over here, host D. All right. What's going to happen is that switch. All right, the switch that frame's gonna be flooded. It's gonna be flooded out to everybody. Okay, all right. So everybody, lottie-dottie, is gonna get a copy of this frame. All right, all right. The frame will be flooded out of. Yes, it will be. The frame will be forwarded. Will be forwarded to host D. Yes, it will. And the other two are wrong because everybody's gonna get a copy of this thing. All right. Which types of memories do switches use to build their MAC address table? Okay, which type of memories do switches use to build their MAC address table? Okay, so that it's in their TCAM. Okay. All right. In the figure, all devices are statically configured with IP addresses, mask, and default gateway information, assuming that all switches have learned the MAC addresses of all devices in the figure. PC1 pings PC4, and PC1 receives replies confirming that the ping works. Which of the following are true about the frames sent in this network in their encapsulated packets? Ooh, okay. So PC1 to PC4, okay. So we got PC1. All right, this is PC1's IP address right here. To PC4 over here, and this is PC4 IP address. Okay. All right. Oh, it's gonna get all messed up when I scroll down. Yes, it will. All right. All right. We need to select two answers. All right. The frame that contains the ICMP echo reply sent to PC4 has the destination MAC address of no. Well, hold on. That one might be right. Number one might be right because again, when a packet goes through a router, all right, when it de-encapsulates and re-encapsulates that packet, okay, it wraps it into a new Ethernet frame. All right. So here's our packet. Okay. Here's our Ethernet frame. Okay, we have a header, trailer. All right. Now, when a router gets a packet, it breaks off the header and trailer that it came in from. So when that frame comes into this router, it takes off the original header and trailer, okay, and then it wraps it into a new All right, a new header and trailer, and then forwards that. Okay, all right. So again, number one may be right. All right, let's just read on. The frame that contains the ICP echo sent from PC1 has the destination MAC address. The frame that contains the ICP echo request sent by PC1 has the destination MAC address. No, boy, the wording is going to get confusing. All right, the frame that contains the ICP echo reply sent by frame that contains the ICP echo request sent by. All right, let's just read the others. All right, the frame that contains the ICP echo request sent by PC1 has the destination IP address of no, because it doesn't do anything to the IP packet. So 3 is wrong already. The frame that contains the ICP echo request sent by PC1 has the destination MAC address of PC4. The frame that contains the ICP echo request sent by the frame that contains the ICP echo reply sent by has the destination MAC address of that. The frame that contains the ICP echo request sent by the frame that contains the ICP echo request sent by PC1 has the destination IP address. Yes, that one's right. The frame that contains the ICP echo request sent by PC1 has the destination. Yes, so that one is definitely right. So the IP packet inside of the Ethernet frame most definitely has. That's never going to change. The IP packet will not change. Okay, the routers do not. They don't do anything to that IP packet. They just take it, they look at it, and then they forward it appropriately, okay? Depending on the information that's inside of that packet, okay? It's the frame that they de-encapsulate and then re-encapsulate on, okay? So no, so this one is wrong. So it's either one of these two right here. And I just have to think about what interface is going to which side is going to have the correct which side is going to have the correct interface, okay? It's either 1 or 2. Now, I want to say it is 2, but it could be all right. Let's go with, we can take a look. If I'm wrong on this one, we can take a look at this more in Packet Tracer, okay? But so what it's saying is the frame that contains the ICP echo request sent by PC4, okay? So what it's saying is when that IP packet gets to this router here, okay? It's picking up 5 zeros, 5/00s MAC address out of his NIC. Okay, so obviously he has a network interface card here, and then he also has a network interface card here. Okay, so the question that it is pertaining is when this PC sends this frame through this router, is it getting 5/0's MAC address going to as the destination for PC4, or when PC4 sends the request back, is it's picking up the 5/00's MAC address. Now I want to say it is the exiting interface that we're picking up that MAC address on. Okay, so we're gonna go with that one. I was wrong. All right. So again, I knew it had to be one of these two. So I had a feeling, but that's fine. Guys, give me 1 second. I just gotta go grab. I'm gonna go grab a bottle of water real quick. 1 second. All right, I'm back, everybody. Sorry about that. Just had to go grab something real quick. All right. So again, yeah, we'll read the explanation here just so we can have some more clarity. In the example, PC1 and PC4 reside on different subnets with one router in between. Yep. As a result, the router de-encapsulates the IP packet holding the ICMP message from the Ethernet frame, discarding the old Ethernet header and trailer, and then adding the new header and trailer. Each frame uses the destination MAC address of the device in the same local area, the same LAN of the broadcast domain. Considered an ICMP echo message sent by PC1, PC2 frame encapsulating the IP uses the IP. Oh, okay. So what it is saying, all right, that whenever a packet goes through a router, okay, it uses the same. So either you look at it as is the entering interface, or the interface that has the same broadcast domain as from where the IP, as where the Ethernet frame originated from that same subnet domain. All right, it's picking up that interface's MAC address as now it's as inside of when it wraps the new header, the Ethernet header and trailer. Okay, when it de-encapsulates it and re-encapsulates it. Okay, it's using that MAC address, that source MAC address now. From that same subnet domain. Okay, so you can either look at it as that, or you can just say simply as the entering interface on that router. Okay, so to keep things simple, we're going to say the entering interface of that router. So the correct answer is when that frame comes through this interface at 500, all right, on router 1, all right, it's going to pick up that MAC address off of that interface and not 501's, okay? Which I had it confused where my logic was saying, is it the exiting interface? Because I was saying, I was thinking when this packet goes this way and then back out here, is it then picking up 50's MAC address? No, all right? In that case, it would have been 501's MAC address, okay? It would have been 501's MAC address. That'd be the source MAC that on that frame going to PC1. Okay, so that's where I got that wrong. All right. All right, let's keep it moving. Which answer encrypts the password that will require a user? All right, that would be required of a user after they type the enable exec command. Okay. All right. So what command encrypts that password? Okay, because remember, when we create a password to just even move into the next mode, all right, that password's still going to come up as clear text on our in our config file. All right, so we don't want our there would be no sense of making passwords, I guess, if they're going to come up as clear text on the file. All right, so we want to use the enable secret. Okay, the enable secret command. All right, which command will generate an SSH encryption key? So that's crypto key generate RSA. Crypto key generate RSA. All right. The exhibit shows some configuration commands that sit in a text file. After adding the configurations to the switch, the user will attempt to connect with the username Fred and the password Hope. Which of the following best describes the accuracy of the configuration for allowing a user attached to subnet 10.1.1.0/24 to SSH to connect to this switch? Okay, so let's take a look at the code snippet here. So we have host name, that's good. IP domain name, yep, they configured that. Username Fred, password Hope, that's good. Crypto key generate RSAs, modulus 1024, that's fine. Interface VLAN 1, they made a management VLAN and they gave it the IP address 10.1.1.1/255.255.255.0 subnet. Yep, that's fine. They're on the same subnet. No shut. Yep, very good. Line BTY 0.0-4. That's good. So, and transportation input SSH and telnet. That's good. Even that. So where they went wrong is right here. The login. They didn't put login local. So by them not putting login local, it is not going to. What's the word I'm looking for? It's not going to register that there is a username password combination to log into this. Okay. So where are we at? So the configuration needs to use the login local command instead of the login command under the VTY 0-4. All right. Which of the two following actions provide the best security for accessing a router's privilege mode remotely? All right. Enabling SSH and disabling telnet, accessing the access using the transportation input SSH VTY command. That sounds pretty good. All right. Configure the enable password command. That sounds even better. There we go. Enable SSH by using the... Nope, that's wrong. Configure the enable secret. Oh, yes. Enable secret. There we go. There we go. We want enable secret and we want telnet. We don't want these two because remember, again, even though I selected it, I was probably just going too fast. So enable password, you can create a password, yes, but it's still going to come up as clear text, okay? And then obviously if you're using telnet, you're insane, all right? Especially if you're accessing something remotely. Because if anybody's tapping in on your wires, everything you type, everything you put into that, over that wire is going to come up as clear text. And I can show you that with Wireshark, guys, if you ever want me to, all right? All right. Refer to the diagram. Both switches are Cisco switches. What would be the state, speed, and duplex of the link reference on switch 1? Okay, so what do we got? Switch 1. Auto negotiate fails because the switch 2 does not use it. All right. So the reason why auto negotiate has failed because some network administrator has gone in and manually put in the speed at 1000 and the duplex at full. All right. So switch 1 though, what switch 1 will do, it'll use the speed because auto negotiate has failed. It will then look for the speed and duplex that other device, that other switch is using. Okay, so it'll be up speed 1000, and duplex 4. So we're good. What are the common local area network layer 1 problem indicators? Okay. What are local area network layer 1 problem indicators? Okay, so we got collisions, and late collisions. All right. Incorrect VLAN. This is layer 2. This is layer. So this is like layer 2 or 3-ish. This is definitely layer 3-ish. All right. So layer 1 is that's the raw deal wires. Okay. You're dealing with old school wiring where that's where you had pretty much one domain and everybody was hooked onto that one domain, and when you sent a frame through that wire, if somebody else was sending a frame through that wire at the same time, there could be possible collisions or late collisions and stuff like that in those old-fashioned setups there. All right, further the exhibit. Based on the information shown in the exhibit, what can be said of the configuration on gigabit 0 on gigabit 0-4? Gigabit 0-4, connected, speed half, duplex half, and speed 100. Again, somebody went in there and configured it for purposely for speed half and 100. So it must be, so that switch must be connected to a hub or something like that. All right, so speed's 100 and the duplex half. All right, further the diagram. Assuming auto negotiate is enabled, what would be the resulting speed and duplex of the link between the switch and host B? So host B, all right. So what would be the configuration? Assuming that auto negotiate is enabled, what would be the resulting speed and duplex of the link on host B? Be 100 and full. 100 and full. Yeah. All right. What is true about the command switchport non-negotiate? So switchport non-negotiate is pretty much telling me I don't want a trunk. No ever trunks. No trunks at all. If connected to a switch that uses dynamic desirable, the neighboring switch will not trunk. Yep. All right. So yeah. So non-negotiable. So when you identify a switch port as being non-negotiating, so that's pretty much saying at any time do you want this switch port to turn into a trunk at all. All right. Based on the figure, what Cisco iOS command would be used on the switch W4 to correctly configure the switch port 501 to access port and to be an access port in VLAN 30. All right. So you just want it to be an access port in VLAN 30. That's easy enough. Switch port access VLAN 30. All right. Refer to the exhibit in the diagram to make it possible. Refer to the exhibit to make it possible for all traffic to pass between PC1's local area network and PC2 local area networks. The link between S1 and S2 will be configured as a trunk. Which Cisco iOS command could be used on switch 1's gigabit 0-1 interface to force it to actively attempt to trunk with switch 2? All right, let's just look at the exhibit. Dynamic auto. And he set that to dynamic auto as well. All right. So if we went switch port mode dynamic auto, all right. Oh, dynamic desirable. So we want switch port mode dynamic desirable. All right. What's that to do is that will pretty much say if you want you can become a trunk port. So that's what the desirable. So to send messages saying, okay, we need to have a trunk here. So I'll be a trunk if you don't want to be, and then it will become a trunk. All right. Dynamic desirable, guys. Dynamic desirable. Okay. An STP topology with three switches. With three switches has one link between each pair of switches. Which answer best describes the primary decision point at which the non-root switch has a designated port on the links between switches, and which one doesn't? Okay. Switches with the highest, nope. Switch with the highest, nope. Switch with the lowest BDI, nope. The switch with the lowest root cost becomes designated, and all other switches will be blocked. Yes, we always want the lowest root cost. The lowest root cost wins the election. Always, the lowest root cost wins the election. All right. All right. In the figure in VLAN 1, all switches have the default STP setting. And all trunks are up and running at 100 megabytes per second. Which statements are true regarding the behavior of STP in the network for VLAN 1 and after the STP topology has stabilized? Okay, so let's read this one more time. VLAN 1, all switches are default to STP. All trunks are up and running. Which statements are true regarding the behavior of STP in the network for VLAN 1 after STP has stabilized? Okay, select two answers. Who's root? So switch 1 is root. So switch 1 is root, and we're looking at that because we're looking at the MAC addresses over here, and switch 1 has the lowest MAC address. So switch 1 is root. Switch 1 will create hello messages regularly based on the hello timer. That's correct. All right, because he's root, so he gets to do that cool stuff. All right. Switch 4 is 501 would become a designated port. Let's look at that. Yes, it will. It'll be yep, 501 will be a designated port. Switch 2, no. Switch 3's interface will become in the forwarding state, the 501. Switch 1 will be forward. So it is switch 4 is 501. Because the 502 be in the blocking state. No. Oh. How did I get this wrong? Because switch port 501 is root port. Oh, it's root port, dummy, not designated port. Root port. Yes, that's where I got that wrong. Just. That's why we do these reviews, guys. That's why I have to keep on doing them. It's got to keep it fresh in my head for the exam. All right. Assuming all default STP settings, which of switch 3's ports will become its root port, and what will its root cost be? All right. So who's root? Who's root? So switch 4 is root, and I'm learning that because of its MAC address is the lowest MAC address here. All right. So it would be 502. Wait. It's gigabit. So fast Ethernet has a cost of 19. gigabit, though, has a cost of 4. All right. I know this because I got this wrong so many times before. So if we had a cost of 4 here and a cost of 4 here, that only gives us 8, where 502 would give us a cost of 19. So it would actually be blocking, 501 would be in the blocking state, where gigabit 001 will actually be root port. So this would actually be root port with a cost of 8. All right, cost of 8. All right. All right. All right. Which of the following are functions provided by span and tree protocol? All right. So it prevents broadcast storms, prevents multiple copies of a single frame being looped, prevents MAC table instability. Okay. All right. Which span and tree protocol mode is an IEEE standard? Which span and tree protocol is an IEEE standard? So we have multiple span and tree protocol, we have span and tree protocol, and we have rapid span and tree protocol. PVST plus and RPSVT plus is Cisco proprietary. All right. 2 switches are connected by 4 Ethernet trunks. 4 VLANs exist with members in each VLAN on each of the 2 switches. The network engineer would like to have the switches treat all 4 trunks as a single 400 megabyte per second trunk, with some of the traffic being forwarded over each of the links between the switches. Which of the following statements are true of such a configuration? Select 2 answers. The 4 trunks can be placed into the same Ethernet channel, achieving their goal. Sort of, kind of, yeah. The show span and tree command will list the combined 4 trunks with the abbreviation PO and port channel. That's kind of true. Span and tree protocol can be used to cause the balance over the 3 or 4 of the 4 trunks blocking. No. Span and tree protocol command will list the combination. No. Okay. So it's the 4 trunks can be placed into an Ethernet channel. All right. And then remember, when you do the show span and tree command, the Ethernet channel will come up as a port channel, so the PO abbreviation. Okay. All right. The configuration when configuring interfaces to be part of the same Ethernet channel, which of the following should you configure identically? Okay. So remember, we need to have the same duplex. You need to have the same speed. They all have to be either trunks or switch ports, okay? All right, so they all have to have the same speed. They all have to have the same duplex. They all have to be either trunks or they all have to be access ports, okay? All right. The exhibit lists output from a switch. Which two statements are true? All right, which 2 statements are true? So remember, the default root cost, the default span and tree root cost is 37,806. Is it 37,806? 37,806. 37,806. I want to say. So we can already tell that this already has a lower root priority cost, all right, than the default. Okay. All of its interfaces are in the forwarding state. All right. All right. So we need to select 2. Switch port. The switch is the root bridge in all the VLANs. I don't know that because I don't know. There are 30 VLANs on the switch. I have no idea. The bridge priority is lower than the default. Yes, it is. All designated ports are in the forwarding state. Yes, they are. All right. If a subnet class B network 172.18.0.0 using the subnet mask 245.245.240 for all subnets, which which answer list an address in the second subnet? Okay. Let's do some mathy math. Now we're getting into some subnetting. All right. So let's write out the question 2 for 5. 2 for 5. All right. What do we got? 240.0. What's our address? All right. 172.18.0.0. All right. Class B network using the subnet mask. For all subnets, which answer lists an address in the second subnet? Okay. So pretty much what we got going on here is let's do it like this. 256 minus 240, all right, gives us 16, okay? All right, so this is going up by increments of 16 here, okay? 16, all right, 32, all right. So what do we got? Which answers list an address in the second subnet? So in this, I mean, at least in this one, we're in between the range. We can be either, we're in the range of 16, and then remember, we got a -1, so 31. So our broadcast address would be 118, all right, 31, 2 for 5. All right, so that's our broadcast address for this subnet ID that we have here. All right. All right, so I'm going to select the first two. Hopefully that's right. All right, because these two addresses are in our range. All right. All right. All right. A size of a subnet is calculated with the formula 2 rise to the h minus 2. What are two hosts? Why are two hosts subtracted for this possible size? Now remember, we're subtracting 2 because we need the subnet ID and then the broadcast address. That's why we're minusing the 2 from the host. Okay, 2 from the host because we can't have because we need. Oh, what's up, baby? Hey, kids, answer the phone. You hear me? Mommy's calling. Yeah. You got it? Call mommy back. My wife's checking up on the kiddos. All right. One host address is reserved for the local broadcast and the subnet broadcast. One host is reserved for the default gateway address. One host is reserved for the subnet number, and the other one is reserved for the. One host address is reserved for the subnet number, and the other is reserved for the subnet broadcast address. What? Yeah, I think you're full of baloney, dude. Dude, open it up. Give it to me. All right. An engineer at the Acme Corporation was tasked with the subnet design for the new branch location. The only information the engineer was given is shown here. Use the 192.168.100 address. All right. Plan for at least 12 different subnets of the same size. Plan for each subnet to have at least 5 hosts per subnet. Which of the answers list the correct number of subnets and host bits in a subnet mask that would meet this requirement? Okay, let's draw this out real quick. All right, so we have 192. 168.100.0. Okay, so he needs to plan for at least 12. He needs to plan for at least 12 subnets of the same size, and plan for each 12 net to have at least 5 hosts per subnet. Okay, so the equation would be, now it's always so to be 2 to the 12th. No, wait. Let's do that again. It's not 2 to the 12th. So let me break out my calculator. Oh, down. Ooh, dropping everything. All right. So 2 to the 3rd. No, it's not 2 to the 3rd. 2 to the 4th. All right, 2 to the 4th. So 2 to the 4th. All right, gets at 16 subnets. Okay, and they need at least 5 hosts. So that would be, it's 2 to the 3rd again. I think 2 to the 3rd was right. 2 to the 2nd, maybe. No, 2 to the 3rd. So 2 to the 3rd, and then 2 to the 3rd subnets, and then 2 to the 3rd gets us 8. So it'll be 16 and 8. So it'll be a total of 4. So 2 answers. So 4 and 4, and 5 and 3. Yep, perfect. All right, guys, excuse me for just one more second. I just got to make sure my kids are doing what they're supposed to be doing and not going crazy. let's get back to it. Unique! Hold on, guys. All right, guys, I'm sorry. Had some technical difficulties real quick. I hope my camera's not broken now. I'm sorry. I don't know how my daughter did that. She tore up my whole room real quick. How she did that, boys. Girl, she did it somehow. Alright. Let's continue on. Alright. So, which two options are true about IP addressing rules? The address in the same subnet needs to be separated. Nope. An address with different subnets. Nope. Address with different subnets need to be separated by a router. Yes. Addresses in the same subnets do not need to be separated by a router. Correct. All right. If subnetting network 192.168.10.0 with the mask /29 for all subnets, what is the subnet address of the fifth subnet? Okay, let's take a look real quick. Let's do some math. So, what do we got? /29. So /29 is 248. So 2 for 5, 2 for 5, 2 for 5, 248. All right. What do we got? 192, 224, 10, 0, 256 minus 248, 248. Okay. What do we got? We got 16, right? Nope. No, we don't got 16. We got, cover that. 16. We got 8. Okay. So we got 8. So what do we got? 0, 8, 0, 8, 16. Okay. Minus that be 15. All right. So our broadcast address will be 192.224.10.15. Okay. So what is the subnet broadcast address of the fifth subnet here? of the 5th subnet. What is the subnet broadcast address of the 5th subnet? Of the 5th subnet. Eight plus 16, 24. And then 24 plus 8 is 32. 1, 2, 3, 4, 5. Minus that would be 31, right? Fifth subnet. I have no idea what it's asking. I'm gonna shoot from the hip on this one, even though I don't like to do that. I kind of guess. I guess what it. I understand where it's going with that. That's cool. Okay. All right. Which option correctly lists the address covered by the indicated address class? Class B addressing begins with 192, 128 to 192 inclusive. No, that's a Class C. No. Class B. No. Class C. This is correct. And it's this one. All right. What are the default masks for each class network? No. No. And it's this one. Which of the following IP mask, IP address / mask combinations, if configured, are working? If configured on a working router interface, would create a correct route for the entire classful network instead of a route for a subnet in a classful network. All right, I gotta read that again. Which of the following IP address / mask combinations is configured as a working router interface would create a connected route for an entire classful network instead of a route for a subnet in a class? Instead of a route for a subnet of a classful network, an entire class instead of a so boo 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 boo. I'm gonna go with that one and say that one. Yep. Okay. A customer support rep at a help desk is working a problem. The problem record mentions his address 172.16.1.1 in mask 25254.0 At lunch and at a lunch and learn session yesterday, the rep heard the network engineer team saying that they avoided the VLSM and used only a single subnet mask in the network 172.16.0.0. Which of the following answers is accurate regarding the implementation of the network 172.16.0.0? Okay. Choose two answers. Each subnet supports 254 hosts. That's kind of right. The network supports 128 subnets. The network supports 512 subnets. All right, let's go with this one first. 254 hosts. And the network supports 128 subnets, or 512. So let's take a look at what we got. We got nine. So it would be 512. Oh, got it wrong on both of them. How did I get that wrong? All right, let's read the explanation on this one, guys. The information of the mask plus the information supplied in the address class. You can find the number of network bits, subnet bits, and host bits. These values in turn define the number of subnets that can be defined used with the subnet design. The number of IP host addresses per subnet. The Class B network, by definition, Class Bs have 16 bits. 16 bits of network bits and 16 bits remaining as to the right as either subnet or host bits. The mask defines the dividing line. The subnet host, subnet bits, the mask of 255, 240, which can be converted to /23 prefix. The sum of it is 16. Oh, okay, I see what it was doing. So there must be 7 host bits. The number of host bits is simply a 32-bit prefix, yep, or in this case 9. The number of subnets in the network, assuming that single mask is used through is 2 to the 7th is 128. Yeah, 512. All right. Hold on. An engineer first confirms that a router's interface 500 is up and working. He then configures the interface with the IP address 10.101.101.101.255.255.128 command. The engineer leaves the configuration mode and issues the show IP command. Which of the following masks will be listed on the output that describes the connected route that exists as the result of the new IP address command? All right, so what do we got? The IP address will be rejected. No, the IP address won't be rejected. Still a valid IP address. So what do we got for 128? 128. B /25 /25. The figure shows an internet network with IP address and default gateways. For some devices, the address has been configured on the routers, and the PCs have been configured using the same subnet mask as the routers on the LANs. A routing protocol has been enabled, and both routers have learned all routes known by the other routers. Which of the following statements are true about the behavior of the IP network? All right. A new PC added to the R1's LAN can be assigned IP address 10. So R1, if that is in the no. All right. Number one's wrong. With 2 IP address assigns, R1's local area network allows for 30 additional IP addresses to be assigned. /28. A new PC added to R1's LAN could be assigned IP address. No, it can't be that one. And with 2 IP addresses assigned, R1's local area network allows for 14 additional IP addresses to be assigned. Okay, let's just do this real quick. Let's break down router 3's subnet real quick. So that is /28. /28 is 240. 5, 25, 25, 240. And what do we got? 172, 25, 25, 25. All right. 256 minus 240, 16. So we got 0, 16, 32 minus 1, 31. All right. So 172. This is the bad one. All right. Where's the good one? Just the new one. This good one. 172, 25, 25, 31. All right. So we have, how many addresses do we have in this range? Is we got our first address of 172, 25, 25, 16. All right. That's our subnet ID. And then we have from that to that. So let's do a little bit of math. What's 16 minus 41? 31. I mean. $15 minus that one address. No. New PC added to the reassign the address. No, it's definitely not that. I'm gonna go with this one, even though I know it. For some reason, I feel like it's not right. But I can't see another answer that would be right. what I'm saying. I knew it wasn't right. Yeah, there'll be only 12 remaining. That's what I figured. Because you got a -2. Yeah, see, why would it give me the address? Yeah. That's such an odd address. The 2 for 5. Like 10.4.4.2 for 5. Um I guess so. Got that one wrong too. Alright. The figure shows an internet network with IP addresses on default gateways for some devices. The addresses have been configured on the router, and the PC has been configured with using the same subnet mask as the router on the LANs. A router's protocol has been enabled on both router. Both routers have learned all routes known by each other. Which of the following statements are true about the behavior of the IP of this IP network? Okay. PC3 is in a different subnet as router R3's local area interface. We'll take a look at that. PC1 should be able to ping PC3. PC3 should not be able to ping PC1, and PC1 is in a different subnet as R1's interface. We got all kinds of hookah-dory stuff to work out here on this one. Thank you very much. All right, got some more coffee, guys. All right. Let's first figure out the router, the actual local area network that we got going on here. So what do we got? /27. So that's 224.25.25. 5, 4. All right, we got 192.168.11.77. All right, 56 minus 224. All right, what do we got? 2, 3/32. All right, so 0, 32, 64. 90, yeah, 96. All right, so we're in between there. 95. So 192.168.11.95 broadcast. Okay, so we have the range between there. So, and that's 64, and the broadcast and the subnet ID would be 192.168.11.64. All right. So our PC1 is not in actual. It's not in the local interface. The PC1 and R1's local interface are not in the same subnet. All right. So they're in different subnets. And PC1, PC3 should not be able to ping PC1. I think we can just go like that for now. Oh, that's what oh. I was gonna pick the one that you couldn't be able to pick. That's what I was gonna pick. Oh, I knew it. I can't believe I did that. That one I'm mad about because I was gonna. I guess I didn't read it good enough. I don't know. I'm getting all McFumbled because when I came back from the other time, all my cameras are on the ground when I came back into my room. So I'm kind of all messed up right now. All right. Which of the following IP addresses could be assigned to a host? Which of the following IP addresses can be assigned to a host? All my stuff's falling again. I don't know what's going on today, guys. All right. Which of the following IP addresses can be assigned to a host? Guess any of them? All right, 127, that's a loopback, so we can say that one's not one. Let's just go with the 207. We were right. All right, the diagram shows a network with the 3 VLANs. The network engineer needs to assign IP addresses to the host to allow them to communicate with each other with which two of the following answers accurately describe the requirement for addressing in this small network. Ooh, I like this. This is the router on a stick. You guys know how much I like the router on the stick. All right. If PC11 is assigned IP address 10.1.1.1, 25.25.25.192, PC12 address could be with the same mask. Woo, we got math to do. All right, let's do some quick math, guys. 10.1.1.1. Oh boy, I'm drawing this all wrong. 192. 192. 25. 25. 25. 192. 10.1.1. 1. 256 minus 192. 4. Carry that. 115. Okay. 64. All right. 0. 64. We're in between that. So 63. All right. So that one could be right. And PC11's IP address must be no. If PC3